Hey there, ladies and gentlemen. Mrs. Matheson. Today we are going to cover Unit 7, Note 6 on secants. We're going to revisit tangents and we're going to talk about angle measures. For our objectives, we're going to find measures of angles formed by lines intersecting or on or inside a circle. We're also going to find the measures of angles formed by intersecting outside the circle. So let's just talk about tangents and secants. Remind yourself that a tangent is a line that intersects in a circle at exactly one point. A line that intersects the circle at exactly one point. Remember that point is called this point of tangency. Also, we also talked about in our 7.5 notes is that the radius is perpendicular to the tangent. The radius is perpendicular to the tangent. So if we draw that in our picture here, perpendicular. If you have a line that's a radius that's perpendicular to a line that touches one place, that's considered a tangent. Okay, so we're going to introduce ourselves to a secant today. A secant is a line that intersects a circle at exactly 2 points. So a little different than intersects than our tangent because it is at 2 points. And when it has 2 points that it intersects, it creates a chord. So here's a secant. Here's our 2 points of intersection. So this is a chord. Creates a chord. All right. So let's see a theorem that is going to involve secants. If two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. All right, so let's talk about that. So if we have two chords, two secants, doesn't matter where they're at, they don't need to match. Okay, so we've created our secants. We have point A, B, C, and D. All right, and they have an angle, and let's call that angle 1 here. Okay, so that measure of that angle, so measure of angle 1 is equal to 1/2 the sum, so that means we're going to add the measure of arc AB, so that's this arc, plus the measure of arc CD. So it's the two arcs that are across from each other, and then that angle. Okay, so if we add those two arcs and divide them by 2, that's going to find us the measure of that angle. Let's use this idea on these problems here. So in number 1, let's add our two arcs, and notice our angle is in between the two arcs. So we're going to add the 2 and divide by 2, same thing as timesing by 1/2, and that's going to get us x. So we have 214 divided by 2, so our angle is 107 degrees. Now let's look at our next one. Problem, our notes, it's a little different. We're going to do problem 3 first. Problem 3, we have our two arcs, but one of them we don't know the measure, so that's x. So we're going to take our 97 plus x, and we are going to divide that by 2. That equals our angle that we've got here. Okay, we need to solve that for x. So we're going to multiply both sides by 2. So we're going to get rid of that divide by 2. So we get 97 plus x equals 220. Subtract the 97, and we get 123 degrees. Remember, these arcs and these angles are going to be all in degrees. Okay, now let's go back to our next problem. So notice here that my angle is no longer on the in-between part of the two x's. So if we had this angle or this angle, then we could just add them and divide by 2. So we have to do some creative thinking. Actually, I'm going to leave this one for you guys to try and see if you can come up with a solution for this problem. Um, use the idea of vertical angles, use the idea that our circle is 360, use the idea that a straight line makes 180 degrees, whatever you need to come up with what our x equals. Okay, one last one. Oh, this one's piece of cake for us. We are given our arc and our arc of x, so 25 plus x divided by 2, we get 60. Again, this is just like that problem 3 we did, times both sides by 2. 25 plus x equals 120, so our x equals 95 degrees. Not a bad job. Okay, so next theorem. If a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is half the measure of its intercepted arc. And really, we have two angles here that are formed by our secant and our tangent. But this is no different than having an intercepted angle. So our arc, AB here, is going to be twice as big as angle, or the angle is going to be half the size of the arc. So if we want to measure of angle 1, it's half the measure of our arc AB. Okay, just like we talked about in intercepted arcs. If we look here at angle 2 is going to be half the measure of arc ACB. ACB tells us that we're going this way. Okay. Same idea, we could think back the other way, that the measure of arc AB is 2 times the measure of angle 1. The measure of arc ACB is 2 times the measure of angle 2. Okay, let's go ahead and use this and apply it. 5 says find the measure of angle P or QPR. QPR, that's this red one here. So that's just asking for half of the arc. 148 divided by 2, we get 74 degrees. Okay, now it says find the measure of DEF. Now we're talking about this arc here. A couple ways we could do this. We can find the measure of the arc DF and then take 360 and subtract that. We could find the angle on the other side and then times that by 2. Let's see here. I'm going to do that. So we have a straight line here, so that's 180 degrees. If I minus out my 64, we are left with 116. So this angle is 116. So that means that that arc is twice as big. So 2 times 116, we're going to get 232 degrees for the measure of arc. I'm going to have you guys try 7. 7 says, find the measure of RQS if the measure of the arc QTS is 238 degrees. And you need to find RQS. You need to find this angle here. Okay, so it's going to use a little more out-of-the-box thinking. Go ahead and finish that. We will come back on the next day, and we're going to talk about that whole second page and those theorems then. I'll see you guys then. Have a good day.